Let's now see more ways in which we can operate over our string values. For this example, we will create 4 new values, and all values will have data type string. Let's now see how we can connect our string values into one specific value. We will create a new variable v5 and we will connect our values from our v1, v2 and v3 variables. When we print value of our v5 variable, output will look like this. Also, we can combine our values from our variables with values of many specific strings. In this example, we created a new variable v6, and now between values of our variables we placed one empty place. When we print value of our v6 variable, output will look like this. We can see that between welcome, Golang and developers words we have one empty place. For our new variable v7, we assigned all values which we already assigned to our v6 variable, and after that we add 2 more values as data type string. If we want to check length of specific string value, we can do that with built-in function len. This function will print specific number of our characters inside of our string value. In cases where we need to take one substring inside of our final string, we will do that with indexing. We will target specific string value, then we will open our brackets, and inside of our brackets we will specify from where we want to start and where we want to end our substring. So in this case, we will print 3 substrings from our v7 string. After we access our v7 variable, inside of our brackets, we specify starting point, then we write 2 dots, and after 2 dots, we specify ending point of our substring. Remember, indexing is starting from 0, not from 1. For first substring, we are starting from 0 index place, which means we are starting from beginning of our v7 variable. Our ending point is index place 7, which means that we will go to 7th place, but we won't count that place to our substring. For the first case, we will have indexing places 0, 1, 2, 3, 4, 5, and 6. We are going to 7th place, but we are not taking 7th index place. The same pattern is applied for second and third substring. For second substring, we are starting from index place 8, we are going until place 14, we stop there, but we don't count place with index number 14. So output of our 3 substrings will be welcome, Golang, and developers. We can also specify our indexing places in different way. Inside of our brackets, for first substring, we didn't specify number. In that case, we will start from index place 0 and we will go until we reach index place 7. For second substring, we are starting from index place 27, but we didn't specify second index place, which means we will go until we reach end of our string. We can do this kind of substring also with assigning to another value. For our new variable, we specified substring in which we will start from index place 0 until we reach index place 7. Then we connect one character to that substring. After that, we connect another substring in which we are starting from 27th index place, and we are going until we reach end of our v7 variable, and after that we are also connecting one specific string value. Let's now see how we can find specific string values inside of other strings. We will create two new variables, value1 and value2. Also, in our import section, we will specify fmt package, but also we will use strings package. This package will help us to find specific values inside of our string values. If we want to check if value1 can be founded in our value2 variable, we can do that like this. We will create new if statement, then we will access our strings package, then we will call our index function inside of our strings package, and we will pass two different input variables. On first place, we will put our string value, which we want to analyze, and for second input variable, we will specify value, which we want to find in our first input variable. This index function will return us specific number. If this number isn't equal with -1 value, then index place of our value1 variable exists inside of our value2 string. So then, in that case, we will print message found. If our index function return us value of -1, then we didn't find our value1 inside of value2. We can do this also in another way. In this case, we passed our value3 variable to our index function, and then we immediately passed new value which we want to find in our value3 variable. Now we are not just checking if that value exists inside of our value3, but also we are returning number of that specific index place. When we print value of our result1 variable, output will be 8, because we find our value2 starting on our index place 8. If we want to find specific value in our string, but on last place, we will do that with last index function. In our last index function, we passed our input variable. Then we want to find last index place on which we find our n character. Let's now see how we can split and join our strings values. For this example, we will create new variables, name and delimiter. We have a new function inside of our strings package, and that function is split. Our split function will take specific string value as input variable number 1, and in second input variable inside of our split function, we will pass specific string value as our delimiter, which will separate our string in a list of strings. Because of that, our split function will return us slice of strings. When we print type and the value of our s1 variable, output will look like this. We can see that type of our s1 variable is slice of strings, and we can see that inside of that slice we have two string values. Our split function can also return us specific index place inside of our slice. In this case, we created a new variable, s2, with our split function, but now, when we separate our name string into our slice of strings, we want to return only value on index place 1 in that specific slice. Now, when we print type and value of our s2 variable, output will look like this. We can see that we didn't return from our split function slice of strings, and instead of that, we have only string type with one specific value. Let's now see how we can join multiple strings values. First, we will create new variable s3 with data type string, and value will be empty string. First way to join our strings values will be with for loop and function range. We will create for loop we will iterate over our S1 slice with function range, and then we will add to our S3 variable new values with our operator plus equal, which means that in each iteration we will add new value to our S3 variable. Now, when we print type and value of our S3 variable, output will look like this. We created a new variable S4 with our join function. In our join function, we have two input variables, where on first place we must pass slice of strings. Then, on second place, we will specify string value which we want to add between values of strings inside of our S1 slice. Our join function will return us string with specific value. Type of our S4 variable is string, and value of that string is created with values from our S1 slice connected with specific string which we passed to our second input variable inside of our join function. We can create another example. We will create a new variable S5, and that variable will be slice of strings with three different values. Now we can print one specific string where we will join values from our S5 variable with one specific string value. Let's now see how we can replace specific string values inside of our strings. For this example, we will create a new variable, quote. Now we want to use replace function inside of our strings package. Inside of our replace function, we will have four input variables. First variable will be string, which we are targeting for replacing values. Second input variable will be value, which we want to replace. Third input variable will be new string value, which we want to put on places where we find our value from our second input variable. Fourth input variable will be number as integer data type, and that number will describe how many times we want to apply this replacement. This means if we assign -1 value, we want to modify all places on which we find value from our second input variable. If we assign to our fourth input variable number larger than 1, that means that we want to replace that number of times our value from our second input variable. Let's now create practical examples. Our new variable S1 will be new string in which we will assign new value. That value will be assigned from our replace function in which we will target our quote variable. Then inside of our quote variable we want to find Golang string value. Then we want to replace Golang value with C++ value, and we want to do that on all possible places. That's why we assigned -1 to our fourth input variable. Now when we print our S1 variable, output will look like this. All this we can do with function replace all. We create the new variable S2, and here we have three input variables. We didn't specify the fourth because there is no fourth input variable inside of replace all function. In this function, we will in any case replace all possible places on which we find our Golang string value. If we create new variable S3 with replace function, but for fourth input variable we specified number larger or equal to 1, then when we print S3 variable, we can see that first place where we find our Golang value is changed to our C++, but second place for our Golang value in second sentence we didn't change. Also, our strings package allows us one specific function. That function is new replacer. This function, new replacer, will create new pairs for our replacement. Welcome value will be changed with our hello value, and that is our first pair inside of our replacer. Second pair contains Golang and C++ values, where our Golang value will be changed with our C++ value. This function has variadic argument, which means that we can assign as many as we want string pairs. How we can call our new R variable? We will create a new variable, result, and that result will also be called with replace function. But now our R variable is calling our replace function, and we are targeting only specific string in which we want to replace specific values. Our replacer will call replace function for our quote string. When we print result variable, output will look like this. Let's now see some other strings functions which can be useful. For this example, before we start to write our functions, we must explain two things. First, inside of our import section, when we specified that we want to use strings package, in front of that package, we typed character S. This character S will be alias for our strings package, which means that each time when we want to access our strings package, now instead of writing strings, we can just write S, and then we will immediately access our strings package. Also, in previous sectors, we learned that function is also data type, which means that declaration of specific function we can assign to new variable. So in this case, our p variable will be our new function, and that function will have declaration exactly the same as our println function from our fmt package. Let's now call our functions inside of our main function. We will call our function contains from our strings package, but now we will use, in this case, alias s for that package. Also, result of our contains function we are getting from our p function. We didn't specify fmt.println, and instead of that we just called p function. So in this case we are checking if our test variable contains es value, and result will be true. In this case, we want to call our count function, and this function will count how many times we founded our t character inside of our test value. Result will be 2. We can check if specific value has prefix or suffix of another string value. In these cases, both results will be true. With function repeat, we can create new string by repeating specific value of string specific number of times. So in this case, in our repeat function, we will specify a value as our first input variable, and for second input variable, we will specify 5, which means that this repeat function will return us string with 5 values of a character. And last, we have 2 lower and 2 upper functions, which can transform to all lower cases or to all upper cases. Beside of these functions, we can see the difference inside of our outputs.